Hey everyone, and welcome to this explainer. If you're a computer science student gearing up for a test right now, you are in exactly the right place. Today, we're cracking the TCP/IP model. Now I know, network protocols can sound like a really abstract, intimidating alphabet soup. But stick with me here, because by the end of this explainer, you're going to walk away with a foolproof mental model. We're going to make sure you absolutely ace this topic on your exams. Let's dive in. Here's our roadmap for today. We're starting with a quick introduction to TCP/IP. Then we'll meet the 4 layers. After that, we'll look at how the layers interact, trace the real-world journey of a web page, and finally, wrap up with the exact exam traps you need to avoid. Just 5 easy, digestible pieces. All right, Section 1, Introduction to TCP/IP. Let's look at the big picture. To really get this, I want you to think of sending data across a network, like running a highly coordinated shipping and logistics company. It's a pipeline, we all know, right? First, you create the item, then you box it up. Next, you figure out the route by slapping a destination address on that box. And finally, you physically load it onto a delivery truck. That is exactly how network data transmission works under the hood. Which brings us to the formal definition. The TCP/IP model is a framework that explains how data is prepared, sent, routed, received, and used across a network, specifically by splitting those tasks into cooperative layers. So why does a layer design even matter? Well, it makes networks way easier to build, troubleshoot, and standardize. Because the tasks are completely separated, entirely different pieces of hardware and software can communicate flawlessly just by following these agreed-upon rules. Moving right along to Section 2, meet the 4 layers. Let's walk through our digital factory. Burn this number right into your memory. 4. There are exactly 4 layers in the TCP/IP model. Not 5, not 7, just 4. And the golden rule for your exam is this. Each layer has its own specific job, but your data absolutely has to pass through all 4 of them. So here is that definitive 4-layer stack. Notice this strict sequential top-to-bottom structure here. We start at the top with layer 4, the application layer. Then we step down to layer 3, the transport layer, followed by layer 2, the internet layer. Finally, we hit the bottom with layer 1, the network access layer, which you'll also hear called the network interface layer. Let's quickly unpack what each department actually does. Starting right at the top, the application layer is the one closest to you and your software. Going back to our shipping metaphor, this is where you actually write the letter. It's the user-facing storefront. Its whole job is to allow your programs to use network services by defining the format of the messages. The heavy hitters you need to memorize here are HTTP and HTTPS for web pages, SMTP for sending emails, and DNS for domain lookups. And remember, this layer doesn't care at all about how the data gets there, it's just focused on the service you're asking for. Next up is the transport layer, and this one manages the end-to-the-end communication. For your test, you've got to understand your 2 shipping options here. On one hand, we have TCP, the Transmission Control Protocol. Think of TCP like certified mail. It tracks the package to make sure you get reliable, ordered delivery. It retransmits missing pieces and makes sure the receiver isn't overwhelmed. On the other hand, we have UDP, the User Datagram Protocol. This is your standard bare-bones shipping. It tosses the data on a truck super fast with lower overhead, but gives you 0 guarantees it'll actually arrive. Send it and forget it. Okay, let's contrast those bottom 2 layers clearly because they're super easy to mix up. The internet layer is all about logical IP addressing. Its core job is routing packets between different networks to find the absolute best path. Below that is the network interface layer, which handles local delivery using physical MAC addresses. Let's bring it back to logistics. The internet layer is the worker writing the final destination address on your box, while the network interface layer is the actual physical truck, the Ethernet cables and the Wi-Fi literally driving that data down your street. All right, Section 3, how the layers interact. Knowing the layers is great, but seeing how they work together is where you really level up. We are talking about 2 massive concepts here, encapsulation and decapsulation. Watch how this flows. The sender creates data at the top and passes it down. As it drops down the stack, each layer wraps the data with its own extra info, first into a transport segment, then an internet packet, and finally a network frame. That wrapping process, that's encapsulation. Then when the receiver gets it, they do the exact opposite. They unwrap the package as it moves back up the stack. That's decapsulation, until the pure data is handed right back to the application. Listen closely to this specific quote from the source material, because it's a huge point for your exam. Reliable transmission is not created by one layer alone, but the transport layer plays a major role when TCP is used. Do not lose points on this. A super common mistake is saying TCP does it all by itself. Actually, scratch that. It's more like all 4 layers have to cooperate to move the data, but TCP is the absolute star player that guarantees the reliability. Let's hit section 4, Journey of a Web Page. Let's actually put this theory into action. So what literally happens when you load a secure website? Step 1. At the application layer, your browser creates an HTTPS request. Step 2. At the transport layer, TCP takes that request, chops it into reliable segments, and handles the tracking. Step 3. At the internet layer, the IP protocol slaps on the source and destination IP addresses so global routers know where to send it. Step 4. Down at the network interface layer, those packets are turned into frames and sent physically over your Wi-Fi. And of course, at the destination server, they just do the whole thing in reverse. Section 5. Exam traps to avoid. Time for a quick quality control check before you take your test. Let's rapid fire through the common pitfalls so you don't get caught. Trap 1. Thinking the application layer is just your actual apps, like Chrome. Nope, it's the network services those apps use. Trap 2. Thinking the transport layer handles routing. Wrong again. Routing packets is strictly the internet layer's job. Trap 3. Assuming every protocol is perfectly reliable. Remember, reliability comes specifically from TCP, not everything else. And trap 4. Confusing network interface with end-to-end delivery. Network interface is just about the local transmission on your immediate network, not the entire journey. So, how do you guarantee full marks on a written response? Here's your ultimate success checklist. You've got to be able to 1. Name all 4 layers in order. 2. Explain at least one clear function for each. 3. Explain how they interact using encapsulation. And 4. Explicitly link that interaction to reliable transmission, calling out TCP. Hit those 4 beats and you've got a perfect answer. To wrap this explainer up, I want to leave you with a challenge to immediately lock in what we just covered. Can you write a short paragraph right now explaining how the TCP IP model helps reliable data transmission using all 4 layer names correctly? Grab a piece of paper and try it without looking at your notes. If you can do that, you have completely cracked the TCP IP model. The big takeaway here is that this is a fully cooperative, layered system. Thanks so much for hanging out with me for this explainer. Keep up the awesome focus and good luck crushing those exams.